Hello friends, this is Priyanka. Today we are going to solve a problem on Bode plot. As this plot is the combination of magnitude plot and phase plot, in this video we are going to plot the graph on semi-log paper with the help of scale. Let us first observe what is the given question. Open loop transfer function g of s is equal to 200 s plus 10 divided by s plus 5 s plus 20. Now for Bode plot we will follow the step by step procedure. So what is the first step? Now if we observe, this transfer function is in the form of pole zero plot and we have to convert it into the time constant form. So what is this time constant form? That is, we have to convert this pole zero form in the time constant, that is in the form of 1 plus st. So we have to convert each term in this 1 plus st. So wherever there is s in this equation, that is here one term is s plus 10, s plus 5, s plus 20. These three terms we have to convert into 1 plus st in this form. That is, these constants 10, 5, 20, these constants we have to convert as a 1. So how to convert? So first I will take this g of s is equal to, now we will take numerator, that is 200. Now s plus 10, suppose I will take 10 as a common, then what will happen? 200 into 10, then s divided by 10, or we can say 1 divided by 10 multiplied by s plus 1. So here 1 divided by 10 means what? That is, I will write 0.1 s, and this 10 divided by 10 means 1. So 1 plus 0.1 s. So this is the numerator, and 10 here we have to multiply with 200 because we have to take it as a common. Then divided by s, I will take s as it is. Then here s plus 5. Again we have to convert 1 plus st form. So take 5 as a common. So if I take 5 as a common, then 1 divided by 5s. So 1 divided by 5 means what? 0.2. So I will write here multiplied by 5 into, in the bracket, 1 plus 0.2s. Now in the same way here we have to take 20 as a common, then 1 divided by 20. So 1 divided by 20, so how we can convert this? That is 0.05. Then I will write here in the bracket 1 plus 0.05s. 1 plus 0.05s. So this is the formation. Now we will simplify this. So how to simplify? So 200 multiplied by 10, that is 2000. 1 plus 0.1s divided by, I have to take 5 multiplied by 20 multiplied by s, that is 100s. Then 1 plus 0.2s and 1 plus 0.05s. Now we will move for the second step, that is sinusoidal transfer function. So we know that we have to replace the s and we have to take, that is j omega. So I will write the equation, that is g of j omega is equal to, now this 2000 divided by 100. So these two zeros I will cancel and I will simplify this as a 20 by s, that is 20 by j omega. Now here 1 plus 0.1 j omega, and from denominator also we have to write 1 plus 0.2 j omega, in the second bracket 1 plus 0.05 j omega. So this is the second step that is getting completed. Now we will move for the third step, that we have to write the corner frequency. So how to write? Let us first understand standard frequency is in the form of 1 divided by 1 plus st. That is coefficient of s, or what is the number with this s is nothing but t, and omega, that is this corner frequency, is equal to 1 by t. So if we observe this whole equation in the second step, then we have to take the numbers with this j omega. So instead of s, we have written here as a j omega. So we have to take as a t. But in this first term, what is t? That is 0.1. In the second term, t is 0.2, and in this third term, t is 0.05. Now if we observe, there is one other term also in the form of j omega, that is 20 by j omega. But this term is not in the form of 1 divided by 1 plus st. So no corner frequency for this term, that is 20 by j omega. So how I can write? So I will write 1 by 1 terms. So this is the first term, that is there are number of terms in the form of j omega, and we have to write it separately. So I will first write 20 by j omega. So for this 20 by j omega, no corner frequency. Then I will write the second term 1 plus 0.1 j omega. So here this is in the form of 1 plus st. So this t is 0.1, therefore omega, that is corner frequency, is 1 by t, that is 1 by 0.1. So how we can write here? That is 1 divided by 0.1, so we can write here as a 10. So this corner frequency is 10. Now in the same way we will move for the next 1 plus 0.2 j omega. Now here this is in the denominator, so I will write 1 divided by 1 plus 0.2 j omega. So again corner frequency is, here t is 0.2, so 1 divided by 0.2. So 1 divided by 0.2, that is 5. Then for the next term 1 plus 0.05 j omega, that is this is in the denominator, so I will write 1 divided by 1 plus 0.05 j omega. So for this corner frequency, again I will write 1 divided by 0.05. So again with the help of calculator, I will write it as a 20, which is equal to 20. So these are the corner frequencies, that is there are total number of terms in the form of j omega 1, 2, 3, 4. 1, 2, 3, 4. So for first no corner frequency, this is the standard form that you have to note down in your notebook, and then these are the remaining corner frequencies. Now we have to select the lowest corner frequency and highest corner frequency. For that we have to observe here minimum corner frequency and maximum corner frequency. Now minimum corner frequency is 5, so I will write here as it is minimum, and maximum corner frequency is 20. Now how to select the lowest and highest range of the corner frequency? Now if we observe the semi-log paper, that is per decade the value varies in the range of 10. That is, for this first decade, I will say that I will draw here the number of lines. So for this first decade, if I take 0.1, then for the start of the second decade, I have to take 0.1 multiplied by 10, that is 1. Then 1 multiplied by 10, that is 10. Then 10 multiplied by 10, that is 100. So these are the range that will increase by 10. So while we are going to select the lowest corner frequency, we have to refer the minimum range. So minimum corner frequency is 5, and this 5 is in the range of 1. So we have to select the one range earlier, that is 0.1. So lowest corner frequency, that is omega CL, is equal to 0.1. Now how to select the highest corner frequency? So for highest corner frequency, we will refer maximum corner frequency, that is 20. So this 20 is in the range of 10. So here in the range of 10, this 20 corner frequency is there. So we have to select one range higher. So one range higher is 100. So we can say that highest corner frequency, that is omega HL, omega CH, that is highest corner, C for corner, H for highest. So highest corner frequency omega ch is equal to 100. So these are the corner frequencies that we have to refer. When we have selected the lowest corner frequency and highest corner frequency, we will rearrange the corner frequencies in particular manner, that is from lowest corner frequency to highest corner frequency. So how we can select? So first I will write this lowest corner frequency WCL, that is 0.1. After that I will take minimum corner frequency, that is phi. So for this phi I will say omega C1, that is this is the first corner frequency. Then next number we will select more than phi, that is it is 10. So this 10 is nothing but omega C2. And then we will select the maximum number, that is the after 10 it is 20. So this will be omega C3. And then last, after completion of all these corner frequencies, we will select the highest corner frequency, that is omega ch, that is 100. So this is the sequence of corner frequencies that we have to maintain in the next step, that is step number 4, that we have to make the table here. So for this table we will first take the column, that is term. Then second column is corner frequency in radians per second, third is slope, and fourth is net slope in dB per decade. Now how to maintain this table? So for this corner frequency we have to follow this sequence, that is lowest corner frequency, then we have to take the higher number, then higher and so on. So this is important step. Now we will select here the number of terms. So out of these 4 terms, 1, 2, 3, 4. Out of these 4 terms, which term we have to take first? Because here no corner frequency, I will select this first term, that is 20 by j omega. So first term will be 20 by j omega. So corner frequency, no corner frequency is there. Now next term we will select for omega C1, that is phi. So I will select here 1 divided by 1 plus 0.2 j omega. So for this corner frequency is phi. Then I will select more than phi number is 10, that is 1 plus 0.1 j omega. 1 plus 0.1 j omega. Corner frequency we have to take as a 10. And next term is remaining term, that is 1 divided by 1 plus 0.05 j omega, and its corner frequency is 20. So these are the corner frequencies. Now we will move for the next column, that is slope. So how to write the slopes? So for that we have to observe the first column, that is for term. So whenever the first column is in the form of s, that is s is in the numerator, then we have to take slope plus 20. When 1 by s is there, we have to take slope minus 20. When s square is there, then we have to take plus 40. 1 by s square we have to take minus 40. When s cube is there, we have to take plus 60. 1 by s cube we have to take minus 60. Now instead of s, if we observe the first column, here we have written j omega. Now for the first term, 1 by j omega, that is 1 by s. So for this 1 by s we will take slope minus 20. Then for the second term also 1 by j omega, that is 1 by s, again I will take minus 20. Then 1 plus 0.1 j omega. So here j omega is in the numerator, that is s. So I will take slope as a plus 20. So all these points are important, because this is the form of whenever there is the s is in the numerator, then we have to take plus sign, and s is in the denominator, we have to select the minus sign. Then here 1 by j omega, that is 1 by s form is there, so I will select here as a minus 20. So these are the slopes. Now we will select the net slope. So how to select the net slope? So for this first I will take as it is, that is minus 20. So we have to carry this number as it is for the first row. Then minus 20, that is minus 40. then minus 40 plus 20, that is again minus 20, and minus 20 plus 40. So in this way this fourth step is getting completed. Now we will move for the next step, that is step 5, magnitude plot. So what is the formula? 20 log of modulus of 20 by j omega. So here modulus is there, we will skip this negative term j. So which is equal to 20 log of modulus of 20 by omega. So first we will take here the corner frequencies in order from the lowest corner frequency to highest corner frequency. We will make here one table, that is first is corner frequency, then net slope, and then magnitude. So for this corner frequency lowest to higher, that is omega CL, omega C1, omega C2, omega C3 and omega CH we have to plot. Then we have to also take the net slope in order as we have made in the previous step, that is step number 4, that is minus 20 minus 40 minus 20 minus 40, and here I will make dash. Now magnitude. So magnitude we will calculate. So first at omega is equal to omega CL. So for this we will use this formula 20 log of 20 by omega. So 20 by 0.1. So when we calculate this, how to calculate? Log of in the bracket 20 divided by 0.1 bracket complete, that is 2.30 multiplied by 20, which is 46.02. So I will simply say 46 dB. So 46 we have to write. Now why this table is important? This table is important to calculate the magnitude for the next frequency. So next frequency is omega is equal to omega C1, which is equal to 5. So how to calculate? So here is the formula. A is equal to net slope. So net slope for the previous frequency we have to take multiplied by log of omega C1 by omega CL plus magnitude at omega CL. That is we have to take the magnitude for the previous frequency. So net slope for the previous frequency is minus 20 multiplied by log of omega C1 by omega CL. So omega C1 is 5 divided by 0.1 plus magnitude at omega CL, that is magnitude at previous frequency, that is plus 46. So again we will calculate this. So first we will take log of in the bracket 5 divided by 0.1 bracket complete multiplied by 20. So here minus sign is there. So minus 33.97 minus 33.97 plus 46. So I will take here 46 minus 33.97, which is equal to 12.03. So 12.03 dB. So this is the magnitude at 5. So here I will write 12.03 dB, or simply we will take here the term as a 12 because 03 is very small term is there. Now we will move for the next. Omega is equal to omega C2. So for the all the next frequencies we will use the same formula. So net slope for previous frequency. So here omega is equal to omega C2, that is equal to 10. So what is the net slope for previous? That is minus 40. So I will directly write minus 40 multiplied by log of omega C2 by C1, that is 10 by 5 plus slope magnitude at omega C1. So for previous frequency we have to refer magnitude, so plus 12. Now we will calculate this. So log of 10 by 5, that is I will simply say log of 2, that is 0.30 multiplied by 40, that is 12.04. So minus 12.04. So here I will select minus 12 because 04 is small term. So minus 12 plus 12, that is equal to 0. So here the magnitude is 0. So I will write here it is 0. So I will write A is equal to. Now next is omega is equal to omega C3. So omega C3 is 20. So I will write which is equal to 20. A is equal to. Now again we will use same formula. So net slope for previous frequency. So what is the net slope? That is minus 20 multiplied by log of omega C3 by C2, that is 20 by 10, plus magnitude of previous frequency, that is 0. Now it is simple to calculate. So log of 2 by 20 by 10, that is log of 2. So I will write here log of 2 multiplied by 20, that is 6. So minus 6 is minus 6.02. So here minus sign is there. So minus 6.02 dB. So I will put here minus 6.02. So this is the magnitude. Now we will move for omega is equal to omega ch, which is equal to 100. So again we will use same formula. So what is the net slope for previous frequency? That is again minus 40. So A is equal to minus 40 multiplied by log of 100 by 20 plus magnitude. So magnitude again for previous, that is minus 6.02. So plus minus, so we can directly use minus. So I will use here log of 100 by 20, that is log of 5 multiplied by 40, that is 27. So here minus 27.95 minus 6.02. So if I add this, that is 6.02, then it will 33.97. So minus 33.97 dB. So I will write here minus 33.97 dB. So this is the table. This is important because we have to take for the magnitude plot these corner frequencies 1, 2, 3, 4, 5. And for these corner frequencies we have to plot the magnitude 1, 2, 3, 4, 5. So we have to take the points on x-axis and y-axis. So in this way, if we refer these two values, then our magnitude plot will be getting completed. Now we will draw the graph for magnitude plot. For that, we have to first select the frequency in radians per second. Now if we observe, lowest corner frequency is 0.1 and highest corner frequency is 100. So at the start of block 1, we have to select the lowest corner frequency 0.1. And then at the start of second block, we have to increase this frequency by the range of 10, that is 0.1 multiplied by 10, that is 1. Then at the start of the third block, we have to again increase this frequency range by 10, that is 1 multiplied by 10, that is 10. And then next is 100 and so on. So here on the horizontal line, we have to select the range 0.1 up to 100 from lowest corner frequency to the highest corner frequency. Now on vertical line, we will plot the magnitude in dB. So our highest magnitude is 46 and lowest magnitude is minus 33.97. We will select here the range from 50 to minus 50. Now we will select here the scale, that is 1 centimeter is equal to 20 dB. That means 1 millimeter indicates 2 dB. So here 1 centimeter, that is first number will be 50, then 1 centimeter, that is 10 millimeter below it is 50. We have to select the next number is 30, then 10, and after 1 centimeter we have to select minus 10. So in between 10 and minus 10, middle line will indicate the number 0. So we have to mention that. Then after minus 10 there is minus 30 and then minus 50. Now we will select the points. Now at the corner frequency 0.1, magnitude is 46 dB. So 46 dB, that means 2 millimeter below 50 dB, because 1 millimeter indicates 2 dB. So we have to take 50 minus 4, that is 2 millimeter below that. So I will select here one point. So this point is getting selected. Now next corner frequency is 5. So this 5 will be in the range of 1, that is this vertical line indicates the corner frequency 1. Then here is the second number. So the second number will indicate the corner frequency 2. Then here is the number 3. It will indicate the corner frequency 3. For this number 4, it will indicate corner frequency 4. And this number 5 will indicate the corner frequency 5. So for this 5 corner frequency, magnitude is 12 dB. So we have to select 1 millimeter above this 10 dB. So I will select here 1 millimeter above this line. So this point is getting selected. Now next is 10 corner frequency. So 10 corner frequency, here is the line. So for this, what is the magnitude? Magnitude is 0 dB. So for this 0 dB, we will select here one point. Then there is 20 corner frequency. So 20 corner frequency will be in the range of 10. So this second line will indicate the 20 corner frequency. And what is the magnitude? Magnitude is for this 20 minus 6. So minus 6 means we have to take below this 0 line 3 millimeter below. So we will select here the point for 3 millimeter below. Then we will move for next, that is 100 corner frequency. So for this 100 corner frequency, minus 33.97. So I will select here approximately minus 34. That is, we have to take 2 millimeter below minus 13. So this point is also getting selected. Now we will join all these points with the help of lines. So I will use here different color. So this is the first line that we have to join. Then we will select the second line. So other 2 points we have to select. Now this each line is having different slope. This is the third line. So all these lines are getting completed. Now we have to select the slope for these lines. Now first line is having slope minus 20. So what is the unit? Unit is minus 20 dB per decade. So we have to write here minus 20 dB per decade. So what is the meaning of decade? Because all this horizontal line or this horizontal section is increasing the frequency by the range of 10. So each section is known as decade, and this vertical line indicates the magnitude in dB. So its a slope is minus 20, that we have made already table. Now for the second line, again slope is minus 40. So we have to write here minus 40 dB per decade. Now we will move for the third. So for this third line, slope is minus 20 dB per decade. So again we will write minus 20 dB per decade. And next one is minus 40 dB per decade. Minus 40 dB per decade. So in this way, this magnitude graph is getting completed. Now we will move for the next step, that is the calculation of phase angle phi. So for that we have to arrange the terms according to the corner frequencies, that is from the lowest corner frequency to the highest corner frequency. So for the first term, which is having no corner frequency, 20 by j omega. Second term for corner frequency phi. Third term corner frequency 10, and last term that is for the highest corner frequency 20. So these are the terms that we have to arrange. So I will say this is the first term, second term, third term and fourth term. Now we will decide how to select the phase angle phi for this each and every term. Now if we observe, first term is 20 by j omega. So whenever this j omega we can say s, because instead of s we can put here the j omega. So whenever this is the form in the equation or term is in the form of 1 by s, we have to select the angle of minus 90 degree. So whenever s is in the numerator, then we will select plus 90, 1 by s minus 90. When s square is there, we will select the angle plus 180 degree. 1 by s square, we will select the angle minus 180 degree. So this is the important tips that you have to note down in your notebook. So this is the form. This first term is in the form of 1 by s or 1 by j omega. So we will select here minus 90 degrees. So this is the first term. So for this first term, I will select the angle minus 90 degrees. Then second term is lower corner frequency is 1 divided by 1 plus 0.2 j omega. Now here 1 plus 0.2 j omega is in the denominator. So this is the form of 1 divided by 1 plus b j omega. So here b is the real number, here 0.2 is the real number and j omega is imaginary, and this is in the denominator. So whenever the j omega term is in the denominator, we have to select the minus tan inverse, that is minus sign is there, minus tan inverse of b omega. So b is nothing but 0.2 and omega we will select as it is. So I will select here for the second term minus tan inverse of b, that is 0.2 omega. Then we will move for the next, that is the third term. So third term is j omega is in the numerator, that is 1 plus 0.1 j omega. So 0.1 is the real number. So 1 plus a j omega, that is equal to tan inverse of a omega. So whenever j omega term is in the numerator, we have to use plus tan inverse. So I will select here, next is plus tan inverse of a omega. So a is nothing but real number 0.1 omega. Then next term 1 divided by 1 plus 0.05 j omega. So here this is the term that is in the denominator. So I will select minus tan inverse of. So minus tan inverse of real number is 0.05. So this is with j omega. So I will use here 0.05 omega. So this is the formula to calculate the phase angle phi. So now we will put here the different values of omega, so including this corner frequency. So how to select? So we know that we have to take from lowest corner frequency, that is omega CL, to omega C1, omega C2, omega C3 and omega CH. From lowest corner frequency to highest corner frequency, we have to select the range. So lowest corner frequency is 0.1, then C1 is 5, then C2 is omega C2 is 10, then here is 20 and here is 100. So these are the frequencies 1, 2, 3, 4, 5. So except that 5 frequencies, we will select the other one also. That is, we will first take 0.1. So whenever we put omega is equal to 0.1, we will get minus 90.86 degree for this phase angle phi. Then we will put the next number as 0.2. So when we put here omega is equal to 0.2, then we will get minus 91.71 degree. Then I will take 0.4, minus 93.42 degree, 0.8 minus 96.8 degree, 1 minus 98.4 degree. Then here next number is 5. So we will take here omega C1 5, which is equal to 122 degree. Then for omega C2 10, we will get here minus 135 degree. Then again for 20, that is omega C3 is 20, we will get minus 147.5 degree. Then for 50, omega is equal to 50, it will get minus 163 degree, and for 100 I will get here minus 171 degree. So these are all the phase angle phi that we have to take according to the frequency omega, and we will plot here for this phase plot with this phase angle phi and according to this frequency that we have taken. Now we will move to draw phase plot. For that we have to first plot the frequency on horizontal line and we have to select the range from lowest corner frequency 0.1 up to the highest corner frequency 100. So this each section represents the increase in corner frequency by the range of 10. So here first we have to take first range 0.1. After one block is getting completed, we have to increase the frequency by range of 10. That is 0.1 multiplied by 10. That is 1. Then here after that we have to select 10 and here is the 100. Now on the vertical line we have to select the phase that is in degrees. So we will select here the range 1 centimeter is equal to 20 degree. Now if we observe this phase angle phi varies from minus 90 to the minus 171. So we will select here the range from minus 50 up to minus 170 degree. So here 1 centimeter indicates the 20 degree. So 1 millimeter is equal to 2 degree. So on this vertical line here is the phase angle phi. Now we will select the points. So first corner frequency is 0.1 and angle is minus 90.86 degree. So we will select here for the 0.1 corner frequency angle is minus 90.86. So we will select here minus 90 degree. Then we will move for the next, that is corner frequency 0.2, angle is minus 91.71 degree. So approximately minus 92 degree that we will select. So here the second line in the range of 0.1 indicates the corner frequency 0.2. So in this line we have to select 1 millimeter below minus 90. So here is the second point. Then next corner frequency is 0.4. So in the range of 0.1, fourth line will indicate the corner frequency 0.4. And what is the phase angle? That is minus 93.42. So we will select here approximately 94, that is 2 millimeter below minus 90. Then next corner frequency is 0.8. So for this 0.8, that is this eighth line will indicate the frequency of 0.8 and we have to select the angle minus 96. That is 3 millimeter below minus 90. So here is the point that is getting selected. Now corner frequency 1, angle is minus 98. So here is also for this corner frequency 1, angle is 98. So we will select here 4 millimeter below. So this is the point. Now next corner frequency is 5. So in the range of 1, this fifth line will indicate the corner frequency 5. And what is the angle? Angle is 122 degree. So minus 122 degree. So if we observe above this minus 130, we have to take 4 millimeter above. That is 1, 2, 3, 4. So this point will indicate the angle minus 122 degree. Then for this 10 corner frequency, it is minus 135. So for this 10 corner frequency minus, after that minus 130, we have to select 2 millimeter below. So here is the point that we have to select. Then for 20, it is minus 147. So 20, that is in the range of 10. This second line will indicate 20 corner frequency and we will select minus 147. So here above this 150 line, we will select approximately 1 millimeter above. So this point will indicate the frequency. Then for 50 corner frequency minus 163. So this fifth line will indicate 50 corner frequency and we have to select 163 degree. That is minus 163 degree. So for this fifth line, we will take 163 3, that means from 170, if we take 7 minus, that means we have to take 3 millimeter above. So we will select this point. And for 100 corner frequency, it is 171. So here, after that 171, slightly below 170, we will select this point. Now all these points are getting selected. Now we will join all these points with the help of line. So I will use here the different color. We will join all these points. So this is the phase plot